Welcome students to this engaging video lecture on the Indian knowledge system presented by the Department of Mathematics at Navroji Varia College. In this session, we'll explore the rich heritage of mathematical concepts and philosophies that have shaped our understanding of the world. Join us as we delve into ancient wisdom and its relevance in today's context. Let's embark on this enlightening journey together. In this video segment, we will focus on key aspects of mathematics from Unit 3 of your syllabus. We'll discuss foundational concepts that not only deepen your understanding of the subject, but also connect with the broader Indian knowledge system. Prepare to engage with these ideas as we explore their significance and application. Mathematics on the Indian subcontinent has a rich and long history going back over 5,000 years. It has thrived for centuries before advances were made in Europe. Its influence spread to China, Southeast Asia, the Middle East, and Europe. Apart from introducing the concept of zero, Indian mathematicians made seminal contributions to the study of geometry, arithmetic, binary mathematics, the notion of negative numbers, algebra, trigonometry, and calculus, among other areas. The decimal place value system that is employed worldwide today was first developed in India. The classical period, which is from 400 to 1600, this period is often known as the golden age of Indian mathematics. This period saw mathematicians such as Aryabhatta, Varahamihira, Brahmagupta, Bascar Aara, Mahavira, Bascar Aara, Madhava of Sangamagrama, and Nilakantha Somayaji give broader and clearer shape to many branches of mathematics. Zero was discovered by an anonymous Indian. The concept of zero in India holds significant historical and mathematical importance. The numeral zero, as we understand it today, is an integral part of the decimal numeral system, and it was developed in ancient India. India's earliest recorded use of decimal system and zero can be traced back to the Indus Valley Civilization, which existed around 2500 to 1500 BCE. However, the concept of zero as a number with its own value and significance started to evolve later. One of the key figures in the development of the concept of zero in India was the mathematician Brahmagupta, who lived around 598 to 668 CE. He made significant contributions to the understanding of zero. He defined zero as a number and discussed its mathematical properties. He introduced rules for arithmetic operations involving zero, such as the addition and subtraction of zero, which are now fundamental concepts in mathematics. Aryabhatta, an Indian mathematician and astronomer who lived around 476 to 550 CE, also played a role in the development of zero. In his work, Aryabhatta used a symbol to represent zero and recognized its importance in mathematical calculations. The concept of zero and the decimal numeral system with its place value notation spread from India to the Islamic world. Islamic scholars like Al-Khwarizmi further developed these ideas, and they eventually made their way to Europe during the Middle Ages. Zero is now considered one of the most fundamental concepts in mathematics. It serves as a placeholder in the decimal system, enabling us to represent numbers of varying magnitudes efficiently. It is also crucial in algebra, calculus, and many other branches of mathematics. The concept of pi, which represents the mathematical constant approximately equal to 3.14159, has a long history in India as well as in other ancient civilizations. In India, pi was known and calculated by mathematicians and astronomers in various ways over the centuries. Indian mathematicians and astronomers in ancient times have made references to pi in their texts. For example, the Shulba Sutras, which are a collection of ancient Indian texts dealing with geometry and construction, include approximations of the value of pi. Aryabhatta, an Indian mathematician and astronomer who lived around 476 to 550 CE, calculated an approximate value of pi as 3.1416 in his work Aryabhatta. He used a geometric method to estimate pi, which was later refined by other mathematicians. Bascar Aara, who lived in the 7th century BC, also provided an approximation of pi in his work Mahabhaskara. He used a different method involving a polygon with 384 sides to estimate pi more accurately. The mathematician Madhava of Sangamagrama, a prominent figure of this school, developed series expansions for trigonometric functions, including pi. Madhava's work predated Europe and developments in calculus and infinite series by several centuries. It's important to note that while Indian mathematicians made notable contributions to the understanding and approximation of pi, the concept of pi and its accurate calculation were also pursued in various other ancient civilizations such as Babylon, Egypt, and Greece. The approximate value of pi, as we know, is 22 by 7 or 3.14159265359. India has a rich history of number systems with significant contributions to the development of various numeral systems. One of the most influential contributions is the decimal numeral system, which is now the most widely used number system globally. The earliest known evidence of a numerical system in the Indian subcontinent can be traced back to the Indus Valley Civilization around 2500 to 1500 BCE. Archaeological findings indicate the use of symbols for counting and recording quantities. The Brahmi script, dating back to around the 3rd century BCE, played a significant role in the development of numeral systems in India. It had symbols for numbers, and these symbols are considered some of the earliest written representations of numerical values in India. The most significant contribution of India to the world of mathematics is the decimal numeral system. This system is based on the number 10 and uses 10 symbols from 0 to 9 to represent all possible numbers. The concept of 0 as a placeholder and as a number itself was developed in India. The decimal system, with its place value notation, simplifies arithmetic calculations and is the foundation of modern mathematics. The concept of 0 as both a placeholder and a number is attributed to Indian mathematicians. The use of 0 revolutionized mathematics and made complex calculations much more manageable. The decimal system with 0 traveled from India to various parts of the world, including the Islamic world and eventually Europe. Islamic scholars like Al-Khwarizmi played a crucial role in transmitting Indian mathematical knowledge to the West, where it became the basis for modern mathematics. In summary, India's contribution to the development of the decimal numeral system with 0 is one of its most significant intellectual achievements. This system has had a profound and lasting impact on mathematics and has become an integral part of global numerical and mathematical notation. Vedic mathematics is a system of mathematics that claims to be based on the ancient Indian scriptures known as the Vedas. It is often attributed to a scholar named Swami Bharati Krishna Tirtha, who published a book titled Vedic Mathematics in 1965, where he introduced and popularized this system. However, it's important to note that the legitimacy and historical accuracy of Vedic mathematics as a distinct mathematical system is a topic of debate among mathematicians and scholars. Key features and claims associated with Vedic mathematics are as follows: Sutras. Vedic mathematics is said to be based on a set of 16 sutras or aphorisms and 13 upasutras extracted from the Vedas. These sutras are claimed to provide efficient and unconventional methods for performing various mathematical operations such as addition, subtraction, multiplication, division, square roots, and cube roots. Vedic mathematics emphasizes mental calculation and claims to offer techniques that allow individuals to perform complex mathematical computations in their heads quickly. Proponents of Vedic mathematics argue that these techniques can lead to faster and more efficient calculations compared to traditional methods. Vedic mathematics is said to be applicable to a wide range of mathematical problems and is not limited to specific areas of mathematics. Proponents claim that it can be used in various fields, including arithmetic, algebra, geometry, and calculus. While Vedic mathematics has gained popularity in some educational circles and has been the subject of books and workshops, it has also faced criticism and skepticism from mainstream mathematicians and educators. Critics argue that many of the techniques promoted as Vedic mathematics are not significantly different from or more efficient than established mathematical methods. Vedic mathematics has been introduced as a teaching tool in some schools and educational programs. It can help students develop mental math skills and improve their speed and accuracy in calculations. In summary, Vedic mathematics is a system of mathematical techniques and methods that claim to be used on ancient Indian scriptures. While it has gained some popularity and is promoted as a way to improving calculation skills. We now talk about a very influential Indian mathematician of those times, the great Aryabhatta. Aryabhatta was an ancient Indian mathematician and astronomer who lived in the late 5th century CE. He is one of the most significant and influential mathematicians and scientists in the history of India. Aryabhatta is best known for his major work, the Aryabhatiya, a Sanskrit text consisting of 121 verses. This work covers a wide range of topics in mathematics and astronomy. In the Aryabhatiya, Aryabhatta introduced innovative mathematical concepts and techniques. Aryabhatta approximated the value of pi as 3.1416, which was a significant improvement over earlier estimates. His work provided a more accurate understanding of the ratio of the circumference of a circle to its diameter. Aryabhatta made significant contributions to trigonometry. He introduced trigonometric concepts and the sine function, which he referred to as Jia. His trigonometric tables and methods laid the foundation for further developments in Indian mathematics. Aryabhatta's work in astronomy included calculations related to the positions of planets, the lunar eclipse, and the solar eclipse. He proposed heliocentric model of the solar system in which he correctly stated that the earth revolves around the sun. The heliocentric idea was well ahead of its time and predated similar ideas in Europe by many centuries. Aryabhatta made contributions to the Indian number system, including the use of a place value notation system and the concept of zero as a placeholder. It's important to note that Aryabhatta is often referred to as Aryabhatta I, as there were other mathematicians and astronomers with the same or similar names who lived in later centuries. Aryabhatta's contributions to mathematics, astronomy, and trigonometry remain significant, and his work is considered a cornerstone of ancient Indian science and mathematics. Aryabhatta was the first of the significant mathematician astronomers from the classical age of Indian mathematics and Indian astronomy. He treated mathematics as a different discipline. Next, we talk about Bhaskaracharya, also known as Bhaskara II or Bhaskaracharya II, was a renowned Indian mathematician and astronomer who lived in the 12th century CE. He was one of the most significant mathematicians and scholars of the medieval period in India. Bhaskaracharya made important contributions to mathematics particularly in the areas of algebra, arithmetic, and calculus. His work Leelavati is one of his most famous mathematical treatises. In this book, he covered various mathematical topics including number theory, geometry, and solutions to mathematical problems. Bhaskaracharya was also an accomplished astronomer. He wrote the astronomical treatise known as the Siddhanta Shiromani. This work is divided into four sections: Lilavati, which deals with arithmetic and geometry; Bijganit, which deals with algebra; Graha Ganit, mathematics of the planets; and Goladaya, spherical trigonometry. In the Graha Ganita section, he made significant contributions to understanding planetary motion and eclipses. Bhaskaracharya's Bijganita is a comprehensive work on algebra. It covers topics like solving equations, indeterminate equations, and algebraic methods for finding square roots. Bhaskaracharya proposed calendar reforms and made adjustments to the Indian calendar system. His insights into the calculation of leap years and the adjustment of months contributed to the accuracy of Indian calendars. Bhaskaracharya's works, especially Leelavati and Siddhanta Shiromani, remain important sources for understanding the mathematical and astronomical knowledge of his era. Next, we talk about Brahmagupta. Brahmagupta was an ancient Indian mathematician and astronomer who lived during the 7th century CE. He was one of the most influential mathematicians of his time and made significant contributions to various branches of mathematics, including algebra, number theory, and geometry. Key aspects of Brahmagupta's life and contributions are as follows. Brahmagupta is best known for his mathematical treatise entitled Brahmasputa Siddhanta, which translates to the corrected treatise of Brahma. This work covers a wide range of mathematical topics and is considered one of the most important mathematical texts from ancient India. In the Brahmasputa Siddhanta, Brahmagupta made significant contributions to algebra. He introduced the concepts of positive and negative numbers, including zero, and discussed their properties and operations. His work laid the foundation for the systematic study of integers and rational numbers. One of Brahmagupta's most famous contributions is his treatment of zero as a number with its own mathematical properties. He discussed zero's role as a placeholder in numerical notation and explained rules for arithmetic operations involving zero. Brahmagupta was also an accomplished astronomer. His work included observations of celestial phenomena such as planetary positions, eclipses, and the positions of stars and planets. He developed methods for calculating the positions of celestial objects. Brahmagupta made contributions to geometry as well. He studied various geometric shapes and properties, including the area of triangles and cyclic quadrilaterals. His work on geometric theorems and proofs was influential in the field. Brahmagupta contributed to trigonometry by developing formulae and relationships involving trigonometric functions, particularly for right-angled triangles. Brahmagupta's work was widely respected and studied in India and was later translated into other languages, including Arabic and Persian, which contributed to the spread of his mathematical ideas to other parts of the world. These are some reference sources that have been used, and this is for your information. Thank you for joining us in this exploration of the Indian knowledge system and its mathematical foundations. We hope this lecture has inspired you to delve deeper into these fascinating concepts. Remember, the journey of learning doesn't stop here. Take the initiative to explore further on your own, ask questions, and seek knowledge beyond the classroom. Happy learning, and we look forward to seeing you in future sessions. Thank you.